We are going to start. This is the lecture number 14 and session 1. I welcome all of you for this session. And today we are going to talk about a very important machine learning model, that is a neural network. Audio and video are clear. Thank you very much. Okay, all right. So my question is, all right. So we are actually going to study a very important model today, that is neural network. Before starting that topic, I want to give you a very important math concept from the geometry, and hope that is not easy, all of you know that, but just for the sake of a starting point, I want to bring this into your understanding. Let's assume that we have a line. Okay, good luck to us. Somebody is rude. What does it mean? All right. So the equation is that, let's assume that 2x plus 3y minus 6 is equal to 0. Okay, if I say this, so can you identify that this is a line? Okay, so if you want to find out that how this line would look like, so let's assume that initially we should talk about what is, when x is 0, what is the value of y. If x is 0, you can say that x is on this particular line. On this line, everywhere the value of on this line, everywhere the value of x is 0. This is the y axis, this is the x axis. So therefore on this line, everywhere the x is 0. So here I can find out that y is equal to 2. So if let's assume 1 and 2, so it means that the line passes from this point. Alright, when y is equal to 0, on this line, on this complete line, y is equal to 0. On everywhere, on all these points, the y is equal to 0. So if I put y is equal to 0, I get x is equal to 3. Okay, can you solve this? It would get 2y plus 0 minus 6 is equal to 0, and therefore you get x is equal to 3. So 1, 2, 3. So this is the point from which the line goes. So since it is a straight line, so by yourself you can see that you can draw a line like this. Okay, is it clear? That if I say that I am going to draw a particular line, and the line is 2x plus 3y, and the line is 2x plus 3y. Okay, so you can draw line this. Okay, this is the line that I am going to talk about. All right, so I am going to rub all these things so that it becomes neat and clean. Okay, all right. Now my point is, this is the equation, and this is nothing more than a linear equation, where I say that, let's assume that this is the system where some item has say v1 and v2, two values, and for that I want to find out the classification. Means every item, that for example if I put a item over here, okay, so what does it mean? So you can say that this item could be 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4. So this item is 3, 4. If I say that there is some item that has the feature values 3 and 4, what do you mean by 3 and 4? So say if it is a mango, I can say the weight and radius. So the two values I can take. You understand that what is the meaning of these are the two values, that I mean two features for a particular item I have taken. So if I want to find out that what is the classification for this, so you recall that what was our method? Our method was that we were using parameter w0 plus w1 x1 plus w2 x2. Okay, and we want to find out what is the sign of this particular item. Okay, we want to find out what is the sign of. If the sign is greater than 0, then it's positive, otherwise it's negative. So here these values are actually x1 and x2. Okay, all right, these values are x1 and x2. So x1 and x2, and given the value I want to find out this. Here if we want to compare all these things, so w0 is minus 6, w1 is 2, and w2 is 3. So we can say like that, want to find out greater than 0. All right, so what is the classification of this item? Okay, what is the classification of this item? We would put this item into this equation. Okay, so if you put these things into the equation comes out to be 2 multiplied by 2 plus 3 multiplied by 4 minus 6. What is the value? Can you find out? 4 plus 12 minus 6 comes out to be 10. Okay, and 10 is positive. Therefore, you say that this item is plus positive. You got this idea or not? That's clear. Okay. If I want to find out the classification of this item, and you know that this item is 0, and because x is 0 and y is 1, you would again put into the same equation. It becomes 2 multiplied by 1 plus 3 multiplied by 2 multiplied by 0, sorry, plus 3 multiplied by 1 minus 6, and this comes out to be 3 minus 6, and therefore minus 3. So therefore you say that this item is negative. Okay, is it clear? All right. Once again, let me find out that what is the classification for this item. So can you tell me what is the equation? Let me just quickly move this point so that it become at some right place. So what is the classification of this item? So if I want to find out the classification, first I want to have to find out what is its xy coordinate. So can you suggest what is the coordinate? X is because x is 2 and y is minus 2. Okay. If I put these things into the equation comes out to be minus 2 multiplied by 2 plus 3 multiplied by minus 2 minus 6, and can you solve this? It is 4 minus 3 minus 6 is equal to it is minus 5. Again you say that this is a negative item. Okay, so we have seen two items which are actually below the line. Any item that is below the line, that falls below the line, is actually negative. In fact, this is the scenario that any item that is above this, if you put into this equation, you would be getting positive. Okay, any item that is below, you are getting negative if you put into the equation. Okay, what does it mean? It means that if you have a line, and in the equation of the line, if you put any point, this particular point, if you put it, you would be getting positive value. Okay, in the equation, if you put any point that is here, if you put these things into the equation is W0 plus W1x plus W2y. If you put this point over there, you would be getting negative. So this is a negative reason. This is the negative reason, and this is the positive reason. What I want to say, that if you construct a line, if your parameter gives you a line, then the lines gives you two areas where in one area everything is positive and other area everything is negative. And second thing that I want to tell you, that you can find out this very easily. It's not very difficult, because just given any point, you just put into the equation and immediately you would be able to tell that whether the classification of this item is positive or negative. Understand? So let's start our discussion. This is needed into the basic. So we are going to talk about the neural network. That is a very important kind of biologically motivated model that we use into the machine learning, and it try to mimic as a brain whatever the things that human the way the human brain behaves for the doing some of the cognitive things and some of the classification, some of the things recall and store. So we want to mimic the same thing into the machine learning domain. Therefore we use neural network. So it was a long back started study in 1943. W. McCulloch, actually they started working that how the neuron works, and then uses that particular model to build a particular program that was adaptive, means adaptive, and it can eliminate the echoes into the phone line. You know that on those areas, in those era, the phone was very basic, and whenever the person is speaking, his voice can also come back. So they wanted to remove this echo, and they have developed first model using the neural networks, and it is called the Medaline. It came out in 1959, and this was the first thing that when the neural network were applicable, shown their applicability. And this model actually was very popular, and many of the time people have thought that it would be able to solve many of the problems that the people have, but unfortunately it was not push this particular model beyond a particular limit in the 90s, and the people were actually saying that key neural network model is actually not going to work and it's a bad model, and however the small things had been done, but it cannot do big things. But suddenly these days what happens that our processing power got very increased. Now we have GPU machines, means a single machine can have more than 200, 300, 500 processing units, and the supercomputer have even a lot of the small processing units, so therefore things can be done into the parallel. And also we have large data that it can push into the systems, and the system can learn using the examples. And these two things actually made possible that we can do the lot of computation in very less time, and therefore it was able to again prove its power, and it can solve many of the problem. So let's just see that how the biological neuron is, our human biological neuron system is. It contains a cell, and with the cell there is some output unit connected. Which what if something is being computed or done over into this particular cell, so it actually sends the signal to the other neurons because they are connected. So one neuron actually sends the things using the axon to the other neuron, and at the end, because this is an axon, at the end it can connect with the another neuron. And let's assume that this is the part where it is going to be connected. So this part, the input for of the next neuron, is actually called the dendrites. So when these two things get connected, axon and dendrites, actually this connection is called actually synapses. So this kind of connection that they make at the time where the things are going to be connected, it is called the axons. So you know that the synapses. So axon and dendrites are actually two different parts, and synapses is a different thing that actually try to match with connect with them. All right. So when the two things are connected, then there is a way to transfer the molecules from one place to another, because how the signal would transfer? Signal would only transfer to the molecule transfer, and when from one place the molecules are transferred to the another things, so we see that how a signal passes from one place to another. So human brain typically have 10 to the power 11 number of neuron. That is a big number, and even nowadays we are into the era of deep learning, and our models are very involving lot of neurons, but even then they are not near to this particular number. This is a very big number, and this is the only reason that we can do very complex kind of task. It is assumed like that. Each neuron is connected to the power 4 other neurons, means 10,000 other neurons on an average, and therefore this is also a very big number. Humans computation, that whatever we do on the machine, they are very less than this particular connections. So even therefore we are very lagging behind with this computation possibility. However, the human brain is very slow as compared to the computers. Computers can, you know that their processing power is into the 10 to the power minus 6 seconds they can do the processing, but here, and even 10 to the power minus 9 seconds they can perform one operation. However, the human brain is 10 to the power minus 3 seconds takes to perform any particular operation, means one switching takes 10 to the power minus 3 seconds, but even then we are better. So what I wanted to tell is the same thing. This is what the model is, and I wanted to highlight only one point that you should understand, that this particular cell I am going to represent as a neuron. Okay, and here are dendrites, means the input things. So these are the input things. Okay, let's assume that there is something input at everywhere. Okay, and what is the input, how the input it is got, you know that there would be some another neuron, and that is going to be connected over here. So this is how the connection is going to be made. And this part, okay, so this part is actually dendrite, and this part is axon, axon. This part, the output is axon. Therefore this whatever output goes from this neuron to next part, it is also going through axon. And this particular thing, how the things are connected, they are different, but they are joined in some way, and this particular kind of connection is called synopsis. So this particular joint is called the synopsis joint. And what is happening inside this? So if you extend this, you can see that there is some part coming from the first, and there is some part that is coming from the second one, and they are connected. Okay. So how the signal are passed? Because if some message is here and that need to be passed to this particular neuron. So how this is passed? Actually, it comes from here, and this part is actually axon, and then there will be some molecules here, and they transfer from here to here, and they transfer from here to here, and because of this transfer there would be some pressure difference and something, and therefore the signal gets generated and it is being transmitted to over here. Okay. Now we want to see that how much strong this connection is, because if this connection is strong, so we say that the weight between this item and this item is very high. It may be possible that this connection, because of these things which are actually connected, so this connection could be strong, this connection could be weak, and therefore that we call that the weights. So this is what uh, the human things are, but when we mimic them into the machine, they looks like this. Okay, the simple model is this, and then we call it perceptron. And the simple perceptron model says that if x1, x2, xn, these are the input, these are the features that you have, these are the values that you have, and they are coming to this particular perceptron. So this is the perceptron. Okay. So perceptron model says that when the things are coming, there is weights. As I told you that this is the strength. You can relate with this as a strength of this particular joint. So weights are there, and then this particular part is actually trying to find out the summation of the weights, summation of the weights with respect to the whatever the input is. So this is not new for you, but because you know that many other time you have by yourself had told me that we are going to have a linear model, and in the previous example from the very beginning we are talking about. This is not a new thing. You understand? This is not a new thing, because we whenever in the linear regression model we talked about this is the same thing, because if these are the x1, x2, xn are the actually features, and these are the weights, and then you have there also you have multiplied this. This is not a new symbol for you. So what is this symbol? Let me just put it over here so that I can write over here. So if you just expand this thing, it comes out to be, okay, if you expand this, it comes out to be this is the W0 plus W1 x1 plus W2 x2 plus dot 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 plus Wn xn, means it is the thing, and this which is written over here means you find out the summation. And when you find out the summation, this is the linear equation. So it is actually going to give you a linear line, and then you want to do a thresholding. What is the meaning of the threshold? If all these things are greater than 0, you know that for just now we have talked about that if your things are here, means above the line, then it would be greater than 0. If it is below, then this is less than 0, that we have talked about earlier. So then therefore there is to do the classification, you need something to find out that whether it is greater than 0 or less than 0. If this computed value is greater than 0, then you say that output class is 1, otherwise class is minus 1, positive class, negative class. That's it. Very simple equation. All right. So let's come back over here. So you understood this part. This perceptron is actually a linear model, and that gives you a linear boundary to separate the items over here. And as you see that sometime, because we have find out the summation, and here I am only going to find out whether it is greater than 0 or not. Sometime it would also be possible that I can apply some function over, because the summation is given to me, I can apply some non-linearity, means I can put a function over here, and if I put a function over here, then it becomes a neuron. And however, this is the simple function available, but if I put some complex function such as sigmoid function, if I put here whatever output that I am going to get, if I apply sigmoid and then want to see, because sigmoid would also give me, if something is greater than 0, it gives 0.5, greater than 0.5, less than 0.5, then the different logic would be used for the finding out the classification. But you can apply these things. If whatever the summation is there, if you apply sigmoid function, Sigmoid is this kind of function. Tan h function is e to the power x minus e to the power minus x. Please note down these things that are very important. E to the power x plus e to the power minus x. So this is the another function. Tan h means whatever this is, this value you are going to get. Let me just take the printout. Come over here and write this. That whatever things you are going to get over here. Okay, why it is not like over here? I call it x. So if you find out x, then you apply a sigmoid of x. If this thing applied sigmoid of on the x, let me just remove this part. So then it is called a neuron. If this is a kind of thing, then I call it neuron. Okay. And this particular function is called the activation function, and various choices we have. One choice is the sigmoid function, that we know that sigmoid is 1 upon 1 plus sigmoid is equal to 1 upon 1 plus e to the power minus x. Similarly, another function are possible, such as the tan h hyperbolic tan. This function is of this kind, and the equation is e to the power, this is the expression that you know, that e to the power x minus e to the power minus x upon e to the power x plus e to the power minus x. Softmax, this function gives is this, it takes log of 1 per plus e to the power x. This is the soft plus function. And rectify linear unit, that is another function, that is also important function, and this function takes only maximum of 0 and x. Okay. So you can see that the various options are available. So which option is better? Many of the times the people, you may think that out of these functions, which function to use? Is it better to use only this thresholding thing, or should I use a sigmoid? Should I use tan, soft plus, rectify? What should I use? Okay. So let me tell you this thing, and this thing. The point is that when you are using these kind of functions, activation functions, then you can include some non-linearity into the system. Means instead of only straight line, it can behave something differently also. So therefore, it is better to use a activation function, because this it is less going to learn, and therefore activation function. If you are going to use the activation function, then its representation power is more. One thing. And when we understood that we should use the sigmoid some activation function, then which function? So this is the sigmoid function, which is the first function of our choice. But if you go for the tan h, you see that what is the difference between tan h and sigmoid? You see that the value comes out into the range of 0. Sigmoid gives you the value into the range of 0, 1. However, tan h gives you the value into the range of -1 to 1. So if something gives you the value into the range of -1 to 1, so one advantage that you can directly see that directly you can use this particular, whatever the output is, you can directly use for the classification. Here you have to again apply something. If the value is greater than 0.5, then I say that it is positive, otherwise it is negative. Okay, but here you can directly use this thing. Another thing that you can directly see, that see the slope over here. Slope is small, and here the slope is large. Okay, so what is the importance of the slope? Slope is how, when you are training the things, if the slope is high, your training is going to be fast. Okay, another function, that is this soft plus function, and this actually removes the negative part, and it also helps see the means sometimes it is more sharper than means you see that what is the problem with the sigmoid and tan h, that they have when the system becomes very much trained, then what happens, that the slope at this extreme positions are very less, and therefore training speed becomes very less. But this function has this advantage that everywhere when training progresses, there is good slope, therefore the training could be fast. Better way, this is another way, that is a rectified unit, that is called ReLU. This ReLU function, and this ReLU function is actually the maximum of 0 and x. And you see that when it is negative, it is just 0, because 0 is the maximum than any negative value. Otherwise, it is the value. So you see that what is the advantage of the ReLU, that it's the slope is constant, means, and slope is constant and fixed. And another very important thing is that computation of this function is very quick, because if you want to train the system multiple number of times, you have to find out what is the value of this expression, what is the value of this expression. You see, if you compare all these four values, so you can see that finding maximum is very easy as compared to the other function, because taking log and doing exponential, doing division, nothing is required. Only you compare the things and you say that what is the value. So ReLU, therefore, it is one of the mostly used functions because it's very fast, and you can many of the time find this particular thing as an implementation into neural networks. All right. So we have discussed that this kind of this is a kind of model that we are going to use, where inputs are there and weights are there. You see that you find out the multiplication of the input things, and sir, I see there are some function. My God, lot of questions are there. I have not taken this. How this? Somebody is asking, all these functions are called neuron. No, when we are going to use these function at this particular place. What is this particular place? This is the perceptron. You see, perceptron model. In the perceptron model, first we do the consolidation, means weighted multiplication. Then we try to see that what should be the output, and to find out that output, this is the only condition, that if this particular value is greater than 0, then we are going to see positive or negative. If we change this function with this particular thing, means instead of using this thing, if we call it x, then we apply the sigma at tan s soft plus or rectify unit over here, and then we find out that what is the thing, then we call this as a neuron. Okay, then this particular model becomes neuron. Sir, what should be the minimum set of operators of the function so that it could be used as activation function? For example, can my transitive function be quadratic function too? Oh my God. Okay, I am going to tell you very simple things. Okay, don't go into the much detail, because they are not, don't get confused. These things are very simple. I'm just telling that here you are these 4 functions. I'm going to give you 4 functions only. So instead of using similarly the linear combination to find out whether what is the classification, I am going to use this particular function, and then I would decide that what is the classification. For example, the sigmoid, when I apply the sigmoid function, I have to test that whether it is greater than 0.5 or not. So similarly, but in the tan h need not to be done anything. Similarly, for the soft plus and rectify unit, we have to do this. All right. Okay, so let's go forward, and then we would talk about that what is the representation power of the neural network, one single neuron. Representation power means how much it can differentiate between the items. Okay, because ultimately its task is to given some positive and negative examples. You have to tell that these are the positive and these are the negative. So how many different items it can differentiate. So a single perceptron can represent many Boolean functions, and any m to m function can be represented by setting all the input weights to the same value and setting the threshold accordingly. So and or not, all these things are possible. For example, just assume this thing, that this is a neuron, and okay, and here the x. First thing I am going to tell that 2 items are given, x1 and x2 are given, 2 input 2 feature are given, and let the weight be minus 30, 20 and 20. Okay, what are the weights? Minus 30, 20 and 20. So you see that what is the summation term comes out to be here. By yourself you can find out. That is very easy. Can you tell me what would be the summation term available? The summation term would be, okay, can you tell me? Summation term would be minus 30 plus 20x1 plus 20x2. This is what this thing going to do. Then you would apply a sigmoid over there. It is telling that. Then I am going to apply a sigmoid and trying to find out what is the value out of this. Consider the following neuron. All right. So when the input is 0 0, can you tell me what is the output? Output is minus 30. All right. So if it is minus 30, then output should be 0 because it's a negative. Okay, for the negative thing, output is 0. Why negative? For the negative it's 0. Again, I would ask this particular simple question, that for the negative it is 0. What does it mean? Okay, how can I say like this? You know this thing. I know that you know that this thing we have computed. This comes out to be for 0 0. It comes out to be minus 30. Okay, what is the sigmoid function? Sigmoid function, sigmoid of the x looks like this kind of function. Okay, what kind of function it is? This kind of function. Okay, So what is the minimum value? It is 0. What is the maximum value? It is 1. Okay, this kind of function. Sigmoid is this kind of function. All right. If this summation is positive, means this is in this area you are, then what is the value of sigmoid? Sigmoid would have value greater than 0.5. It would have the value greater than 0.5. If this thing is negative, I just need to find out what is the sign. If this value is negative, then what is the value of sigmoid? It is less than 0.5. I know if it is less than 0.5, it is a negative example. If it is greater than 0.5, it is a positive example. Okay, so putting into the sigmoid function means nothing more than that. Just check what is the sign of this inside thing. If W transpose X is greater than 0, then it's a positive thing. If it is negative, then it is a negative example. Straightforward. All right. So let's continue with our example. So can you tell me what is the value when x1 is equal to 0 and x2 is equal to 1? It is 10. Means it is a positive example. Okay, how can it is 10? Minus 10. Okay, then it is 0. Okay, you got me confused. Please don't solve like this. If it is 1 0, then again the output would be, you know the equation, 30 minus 30 plus 20 x1 plus 20 x2. It comes out to be minus 10. Therefore, the output would be 0. If it is 1 1, when the input is 1 1, then what is the output? Minus 30 plus 20 is equal to 10. All right, and therefore the output is going to be 1. If I say that input can only take these values 0 0 1 0 1 1 this, so you can you find out this table? It is an AND. It computes the logical AND operation. Okay, AND is when both the things are 1, then it is 1, otherwise 0. It is computing logical AND. So similarly, if weights W0 is minus 10, then it becomes OR operation. If you put here minus 10, then it becomes OR operation, means the output is R. If W0 is 10 and W1 is minus 20, then the sign single input gives the NOT output. So similarly, you can find out AND or NOT, all the different kind of circuit things you can generate. So you see that every circuit that looks, if you can generate AND or means NAND, if you can generate, then basically using NAND is a kind of universal gate. So you can use that thing to generate any circuit. In the circuit theory, people know that if you have a NAND gate, NAND can give you AND, OR, NOT, everything, and using that thing you can generate any circuit. So if you want to build a circuit, you can directly utilize it. All right, sir, somebody is asking, sir, what about sigmoid significance? I told you then, I just pointed out this thing, that what is the significance of the sigmoid, that if it is positive, it gives you +1, otherwise negative. The sigmoid makes you function like that. All right, so we have seen this. So next, it represents a decision boundary. So we have seen that whenever we fit the parameters over here, it represents a decision boundary. For example, this thing provides positive classification if this value is greater than 0. We have already discussed the decision boundary represents a line. This is the line. If you plot this line, minus 30 plus 20 x1 plus 20 x2 is equal to this line comes like this, and this is the positive region, means for this point that is above this particular line, it is a positive region, and here it is a negative region. You see this. We have discussed this before starting the class. Also, we have discussed the same thing. So we have found out that neurons that when we set the weights, they are the linear separated boundary. So it's kind of mathematical. Looks kind of what we say. It's not a very difficult task, because we have from the very beginning in the first class itself we are talking about these things. So most important part is this, that if you have a neuron, means if you define a neuron, means you set up the parameters, then you can arrange them into layers. The most important part is this, that you put the input layer, means these are the things initially, these are not the neuron, actually neuron are here. This is the first neuron which is connected with every input, and there are associated weights there. Similarly, this is again a neuron that is connected to using what I mean by this. Let me take it out and put it here. Okay. What I want to say that let me just say that this particular thing, that let's assume that your x is x1, x2, and x3. Okay, 3 values are. you put x1, x2 and x3. Okay, and this is the neuron 1 neuron. This is the first neuron, this is the second neuron, this is the third neuron, this is the fourth neuron, this is the fifth neuron, this is the sixth neuron, this is the seventh neuron, this is the eighth neuron, ninth neuron. Okay, so this neuron is connected with all the data items. You say the weight 1, W1, W2, W3 weights are. How this neuron is going to take the decision? It is going to multiply W1 x1 plus W2 x2 plus W3 x3 plus some W0 is greater than 0 or not. If it is greater than 0, then it gives the high activation to this line, on this line, on this line, on this line. Okay, 0 or 1 the output. Let's assume the output is 0 and 1, and here weights are there. Similarly here also the weights. This is the second neuron. So weights with respect to the neuron would be different. W, W1, W2, W3, but these are with respect to 2. So I can also include W21, W31, kind of this. So different weights are there. Here also different weights are associated. Different weights are associated, and but this output, this output, this output, this all 4 output are the same. Similarly, these 4 outputs are the same, but when they go into this next neuron, then there would also be again the weights. Okay, and these weights are different than the maybe different than the others, and they are actually need to be defined, find out, so that the things are perfect. Now you see that this would again give you some input, and here again we have weights, and this would be able to give you some activation. Okay, so this when we build the new layers of the neural networks, means in one layer multiple neurons are there and the multiple neurons are there, then it is called the neural networks. Then this particular model is called the neural networks. Okay, any Boolean function, important thing is that, can be made with a neural network of only 2 levels deep. Okay, any Boolean function can be made only 2 levels deep. That is a very important thing to know. How can I utilize this? Let's assume that you have an image, okay, and you want to find out there is a cat or dog. Okay, so if your image is say 20 cross 20, small image, let's assume that small images, how many pixels are 20 cross 20, 20 cross 20, 400 pixels. So these things are not 400 input would be there, because image, you take the image, every pixel you feed to the neural network, and here every neurons which is here, how many inputs would be given? 400 inputs would be given. If the image is 20 cross 20, 400 inputs are given. So is how many neurons I should put over here? That we would decide later. Let's assume that I had put 50 over here, then 50 over here, and connected, and at the end the last one is the output of these things are connected, and at the end it tells you 0 and 1, because ultimately it is going to give you the 0 and 1 only. So the output, if I put the sigmoid function, output could be, if it is unthresholded, the output could be any value, and if it is a thresholded thing, then the output would be 0 and 1 with the classification. Okay, output would be the classification. With thresholded, then you are going to see the 0 and 1. So what do I mean by 0 and 1? If I had given an image, what does it mean by 0 1? 0 and 1 could be that whether there is a dog in the image or not, whether there is a car there is or not, whether there is a cat in the image or not. Alright. So given the image, you can train the model. How to train I am not talking about, we will talk later. Okay, but if we find out the appropriate parameter into this neural network, then given the image, the output would tell 1 if there is an image, if there is a dog, otherwise not. Somebody is asking why 2 level deep. No, you can make it 100 level deep. That is not a big issue. But point is that using only 2 level deep, you can make any Boolean function. This is what the representation power is. Okay, means, but you have to increase the number of neurons over here. That we are not going into the much detail, because then you can make very much mathematical. I think you understand this part. That single neuron represents a decision, a linear boundary. Okay, multiple neuron, if you are combining, they make the complex boundary, and using those complex boundary you can perform very complex kind of operations, and that's why you build the neural networks. Now a point comes that I don't want to discuss just now, that why we are not increasing many layers over here. The reason is this, that training becomes very difficult because number of parameter increases and therefore training becomes very difficult. If you are having very large network, means if it is 10 layer deep, then you would not be able to train it because the differences that are going to be passed, it is called the vanishing gradient problem. That means that whenever you want to change the thing, you go using gradients and gradients becomes very small and therefore you cannot train. So we are not going to much detail because they would become mathematical. I just want to tell you that if it is very much deep, then it would be very difficult. Somebody tells, sir, why 2, why it is not 1? 1 is a simple regression. 1 would give you only single line. Okay. So therefore 2 level, even any complex function you can make using 2 levels. Alright, sir, is the neural network just set for Boolean function of 2 level? Alright, I would take the questions, but at this moment, if you are with me, please let me know that you understand all these things. That this is the input, means all the things, all the features are coming over here, and then you put multiple neurons over here, and they are actually every neuron is getting everything as an input, and then it passes. And in the next layer, what is happening, that it is connected with everything into the previous layer, and this way we create the layer. Multiple layers can be created. At the end, there would be a single neuron and that would take the input from all the things that are there and it consolidate and try to find out is 0 and 1. If appropriate weights are set at each level, then we can find out a right kind of conclusion, such as whether there is a cat or not, whether there is a dog or not in the image, any kind of thing you can, whether there is a circle or not, kind of a 1 and 0 kind of equation, things you can find out. Alright. Okay. Now I have a question for you. Okay, so let's assume that x1 and x2 is 0 0 1 0 1 1 0 1 1 and the classification for them is 0 0 1 0. So can you design a neuron for me? Can you design a neuron for me? Can you give me the a single neuron for this? Okay, this is a question. Okay, now you have to tell me that what should be the right weight. Okay, what should be the right weight? Alright, somebody is asking XOR. No, it's not XOR. XOR here should also be 1. But I am going to give you a arbitrary equation. So ultimately what I am asking you that let's say you are going to, because 2 inputs are there, X1 and X2, these are the inputs, and then one bias term is there, 1, and how many weights are? 3 weights, W0, W1, W2. You have to tell me that these, what are the weights. Okay, so that when I apply a sigmoid function, so this multiplication become positive for these values and negative for these values. So how to go ahead with this? Very simple. You write 4 equations. What are those 4 equations? That when the first input is given, means when first input is given, then what is the equation formed? W0 plus W10 plus W20. It should be W10 plus W20 should be less than 0 because the output is 0. Are you with me? Can you see this equation? Is it right? Yes? Very good. Alright. So what is for the second thing? W0 plus W1 0 plus W2 1 is less than 0 again. And next equation is W0 plus W1 into 1 plus W2 into 0 should be greater than 0 because it is, then only it can give you 1. And the third equation is W0 plus W1 into 1 W2 is less than 0. This is what we have. And Anand has solved this. I am very happy with you. He has come up with the values at minus 30, 20 and 40. Alright, yes. Then you would be solving this thing and solving by 1. You see that the W0 is negative. So let W0 be minus 1. By first thing we got W0 is negative. So let me set that W0 is equal to minus 1. And by second equation W0 plus W2 is less than 0. You W1 W2 less than 0. So let me set W2 is equal to minus 1. And then by the third equation you say that W0 plus W1 greater than 0. So you say W1 is equal to 1.5, so that it becomes greater than 0. These values you have already set up. Now summation of all these things should be 0, and by chance using this thing it is valid. So therefore our solution is W0, W1, W2 is equal to minus 1, 1.5. You can see that various things are possible. In fact, any linear combination is also right. Other possibilities are also there. So this is how you find out that what should be the weights. But this is not the right way to go, because here we are solving the things, and you can solve for the small set only. So we would be trying to see that what is the training approach that you can follow. Okay, so sometime you can create this kind of scenario also. For example, if this is C, you can make some jugglery, and this kind of network would also be fine. Means you see that if you say that x2 bar, and then you can take the AND of those things, and you know that how to take the bar, na, and you cannot use those things to find out these things. Okay. All right. So this is how we go ahead with this. So bar is complement, all right, yes, because if you take the bar and this is complement. Okay, so there are various applications of the neural networks. It is appropriate for the problem with the following characteristics. Instances are represented by many attribute values pairs, means when your dimensionality of the data is high, and the target function output may be discrete values, real valued, or means real values are given to you. The training example may contain error, and this was the biggest problem. Look, this particular point was biggest problem into decision tree, because in the decision tree, when something comes that that is not a discrete value, then you have to change this into the discrete value. But here it is not required. Immediately you can feed the value. Therefore, that is a good thing. Also, it is applicable for the places where the training example may contain errors, because it gives you the best suited boundary. So therefore, error can be accommodated. Long training time are acceptable because it takes a lot of time to train, because this is the one most biggest problem that neural network has, that it takes a lot of time to train. So if you can give me a long time for the training, then I can give you the good neural network. Okay. And the biggest advantage that by the neural network is this, that when you train your model, whether your your model is ready, then you can immediately feed something to get the output. Okay, what I might mean to say, that there are two things, that I am going to give you the training example, give you the model. It would take say 10 days, but for the new item, if I give you and I ask the classification, it is within steps. Within single minute, you pass these things into the network, get the answer. So when you want to be very quick into producing the output, then you should use this. Because for example, if we are going to make a automatic driverless car, so what would happen? That you can say that training would take one month. That is fine, because I would not drive for that 1 month. But when I'm driving, if somebody suddenly comes in front of me, then the car should act very quickly. So my system would act very quickly when it is into the operation. But to make the system right, it would take a lot of time. Okay, so fast evaluation of the learned target function may be required. So this is what it is, but the training time is large. Okay. And also very important thing, this is the final line, that is a very important line, that nobody asks me that why it is going to it is doing right thing. If you are asking that how come, what is the interpretation of this weight, how it is collected, if you start understanding this, then sometime it may be possible that the giving this right kind of interpretation may not be possible. However, I have given one interpretation, that there is a line that interpret the things, but if it is a big network, then having the interpretation is very difficult. All right, the ability of human to understand the learn target function is not important, then you go for this, and most of the time it is not important, because you want to find out the answers. All right, so now we have understood that what is the neural network, what is the neuron, and now it comes to us that how to train this particular model. All right, so there is one way to train, this is called the perceptron training model, and I'm going to leave this slide in front of you. We would be discussing into the next session. So we are at the right place where we can take a break. So I'm going to have a break at this moment. So in case you have any questions, you can ask. But how to train this, it is remained. Then we will be talking this into the next session. All right.